Hi, welcome to another IGCSE physics video. In this video, we're looking at part 2 of section 2.3, which is about gas laws. We're specifically looking at the first gas law, which is Boyle's law. In this video, we will do a quick recap on what Boyle's law is, and then we will do some physics problems involving Boyle's law. In part 1 of section 2.3, we learned that the product of pressure and volume can be represented as the proportionality constant of those two variables. We also learned that the pressure is going to be inversely proportional to the volume of the gas. And in terms of mathematical equations, you can represent it as PV equals to K and the pressure being proportional to 1 over volume. In other words, the pressure is inversely proportional to volume. In part 1, we also did an experiment exploring how the pressure and volume are related when given constant temperature. We learned that if you have a gas which has a pressure of, say, P1 and it has a volume of V1, and we had another gas which had a pressure of P2 and a volume of V2, then the product of both of the pressures and the volumes will be equal to K, if and only if the temperature of the gases is constant. Hopefully this recap helped you remember the concepts of Boyle's law. If you're still confused, you can check out part 1 of section 2.3, which covers Boyle's law in detail. The link will be in the description. Now that we're done with the recap, let's do some physics problems that will apply Boyle's law. So we're given this first question, which says that an ideal gas occupies a volume of 2 cubic meters at a pressure of 200,000 Pascal. The gas is compressed to 1 cubic meter. What is the new pressure of the gas? It's good to read the problem again and identify some key features of the problem and the stuff that you will be using to solve this problem. The first thing we're told is that this gas that we're compressing is an ideal gas. We know that the gas laws will only work for an ideal gas, so we can apply this law on this question. We're initially told that it occupies a volume of 2 cubic meters, and it has a pressure of 200,000 Pascal. So we can start writing down our values for these. So P1 will be called the pressure of the gas before it's compressed, which is 200,000 Pascal. And we will call V1, which is the first volume before the compression, and it's going to be 2 cubic meters. It says that the gas is compressed to 1 cubic meter, so that's one more key thing that we can jot down. And we will call this second volume, which we get after the compression occurs, V2. So V2 equals to 1 cubic meter. Now the question is asking you, what is the new pressure of the gas? So we can say that this is the missing part of the question, and we will call this new pressure of the gas after the compression P2. So we know that our 4 variables in this question are P1, P2, V1, and V2. We know P1, V1, V2, but we don't know what pressure 2 is. So we can start plugging in our values into the Boyle's law, and we can just solve for P2 using algebraic manipulation. And we would get that 200,000 Pascal times 2 cubic meters equals to the second pressure, which is the pressure after the compression occurs, times the volume after the compression, which is 1 cubic meter. And we could divide each side of this equation by 1 so we can get rid of that 1 cubic meter. And we should get that the second pressure, or the pressure after the compression, is equal to 400,000 Pascal. Now the final thing that we have to do with this pressure that we got is to determine if this answer is reasonable, based on the Boyle's law that we used as well as the question that we were given. So from the question, we knew that the pressure before the compression was 200,000 Pascal, and the volume was 2 cubic meters. After the compression, we found out that the pressure was 400,000 Pascal, which is twice as much as the pressure before the compression occurred. And the volume is now not doubled, but it's in fact halved from the original volume that we had. So we went from 2 cubic meters to 1 cubic meter, whereas the pressure got doubled from 200,000 Pascal to 400,000 Pascal. So I think that this answer seems reasonable because we can see that the volume is decreasing after the compression and the pressure therefore increases And we know that this determines the inverse proportionality of pressure and volume, which we can see in Boyle's law. Here we're given another question regarding Boyle's law. We're given that gas A initially had a volume of V and pressure 0.25 P. The gas underwent an isothermal process which caused the pressure to become 4 P and an unknown new volume. And we're asked to find the type of isothermal process as well as the new volume of the gas. Let's go through this question again and identify some values and key points. So we're given gas A initially had volume of V. And we also know that it initially had a pressure of 0.25 P. So we could write this down as initially the pressure equals to 0.25 P and volume equals to V. And then we're given that the gas underwent an isothermal process. Recall what isothermal means. From its roots, it means it's the same temperature because iso means the same and thermal has to do with like heat and temperature stuff. So this means that the temperature of this process that's happening is the same. So based on Boyle's law, we can apply P1 V1 equals to P2 times V2. And we're told that because of this isothermal process that this gas underwent, the pressure of the gas became 4P, and then we created an unknown volume of the gas. So we're asked to determine what the type of isothermal process is, as well as the new volume of the gas. So we're being asked two questions here. Let's do the first question where it's asking to determine the type of isothermal process. We know that in IGCSE physics there can be two types of processes where you can have a gas expanding from a smaller volume to a greater volume, or you could compress a gas from a greater volume to a lower volume by applying some pressure. Based on Boyle's law, we know that if you increase the pressure of a gas, then the volume of the gas decreases because of the inverse proportionality between pressure of a gas and the volume of a gas, given that the temperature of the gas is constant. And we also know that if the pressure of the gas decreases, then the volume of the gas will increase for the same reason of inverse proportionality. Note that we're given that the pressure of the gas originally is 0.25 P. And after the isothermal process, the pressure of the gas becomes 4 P. Now 4 P is 16 times as big as 0.25 P. So if you multiply 16 by 0.25 P, that will be your scalar factor that will give you your new pressure of 4 P. So we can see that the pressure of the gas is increasing, and therefore the volume of the gas must be lower than V, which was before the compression or the expansion occurred, which we're about to find out. So because the pressure of the gas increased from 0.25 P to 4 P, the volume must have decreased, which means that this is an isothermal compression because the volume will be decreasing in this situation. When you have a pressure increasing, the volume of the gas will always decrease, making sure that the temperature of the gas is always constant. Now let's look at the second part of this question where it's asking you to find as well as the new volume of the gas. So we already know what the original pressure of the gas is and the original volume of the gas. We know that after this isothermal compression occurs, the new volume of the gas becomes 4 P. And we don't know what the volume is. Our first step in this would be to use Boyle's law, which says that P1 times V1 will equal to P2 times V2, which is only in the condition of constant temperature, which it is because this is an isothermal compression. We can say that P1 will be equal to 0.25 P and V1 will be equal to V. P2 will be equal to 4P and V2 will be equal to our unknown value, which we will solve for. So we can multiply these values. So our equation will turn out to be 0.25P times volume equals to 4P times our second volume. We need to solve for V2, which will be the new volume of the gas. And the only way we can do this is by dividing each side of the equation by 4P, which will leave us with only the variable V2, which is what we're looking for. So V2 will be equal to the 0.25P. times the first volume of the gas, which is in V, divided by the pressure of the gas, which is after the compression occurs, which is 4P. So we can divide this 0.25P divided by 4P. The pressures will cancel out, which makes sense because we're supposed to get our units in volume. And 0.25 divided by 4 should give us 1 over 16. So V2, or our final volume, will be equal to 1 over 16 of V. And this is it for section 2.3 part 2. Leave a like if you found this video helpful and subscribe for more videos in the future. And you can check out some of my videos in the description, which will be linked, related to pressure if you're still confused on that. And I'll see you in the next video. Thanks for watching.